So our next chapter is complex number. It is very important for our SAT examination. So in this chapter we learn about the imaginary number, I, that is called iota. Iota is addition, subtraction, multiplication, and at last division. So in our SAT examination the question is mostly asked about this concept like addition, subtraction, multiplication, division of imaginary number. So in order to start our chapter, first we see what is the iota, what is its value, and there is a question always related to the power of I. It means that basically what is the power of I 2025, I 50, power of I to the power 25, power of I to the power 30. This type of questions are basically asked in our SAT examination. So first we have to learn about the imaginary number I. What is I? I is nothing. I is equal to root and minus 1. It is the value of I, and the I square value is equal to minus 1. IQ is equal to, we can write IQ I square into I, and here the I square value is minus 1, and I into I, we can write IQ minus I4 we can write it as I square into I square. I square is equal to minus 1 into minus 1, that is the 1. So these four are very important because we can write I minus 1 minus I. When we learn these four things, then we can find power of anything else or any power of I. Suppose we have a I to the power 50, we just have to divide 50 by 4. When we divide 50 by 4, we get 12 and get remainder 2. So we get remainder 2, and we can write I 42 48 into 2. So it is the division by 4, so we can write directly I 48 is equal to 1 and I square is equal to minus 1. So answer is minus I. So first of all we have to divide any number by 4. If the number is divisible, then we have to write that number separately, and after remainder number we have to put it separately. Suppose we get I to the power anything of 26 and we get I, then just we have to put 26. Suppose that is the, it is divided by 4, that is I over 6, so we can write I to the power 24 is just 1 and I to the I is equal to I. If there is I square, then we put I is equal to square minus 1. If there is IQ, then we put IQ in place of minus I. If there is I to the power 4, then it alone will be divisible by 4. We can also write I to the power 4 is equal to 1. So basically these are the things which are related to the imaginary number. Now let's see its structure. Basically complex number is the combination of imaginary number and real number. Here this is a real part or this is imaginary part, and B is the number which belongs to the real number. So this is the real part, this is the imaginary part. So Z is equal to a combination of real and imaginary number. Now we have to see the addition, multiplication, division and subtraction related to the imaginary number. So for addition, let's see addition of complex number. There is a Z1 is equal to example 3 plus 2 iota, Z2 is equal to 2 plus 3 iota. When we have to add this imaginary number, we just have to be add 3 plus 2i plus 2 plus 3i. In this part we have to add real part to real part, imaginary part to imaginary part. So 3 to 5 iota. We can't add real and imaginary, and like 3 plus 3 is 6, 2 plus 2 4 iota. We can write like this. We have to be add real to the real part, imaginary to the imaginary part. In subtraction it is similar concept. Let's see. uh, z1 minus z2. Suppose z1 is equal to 3 plus 2 iota minus 2 plus 3 iota. In this concept also we have to be add real to, we have to minus real from real, that 3 minus 2 1, minus imaginary from imaginary, so we can write 1 minus iota like this. You just have to do the addition and subtraction, real to real, imaginary to imaginary. We can do real and imaginary together, imaginary and real together. We just have to do separately. Now multiplication. In multiplication we can multiply real and imaginary and real. Let's see example. z1 into z2, 3 plus 2 iota, 2 plus 3 iota. First of all we have to multiply 3 to all, and then after 2i to all. Let's like this. 3 into 2 plus 3 iota, 2i, 2 plus 3 iota. When you multiply 3 to 6, 3 3 to 9 iota plus 2 to 4 iota plus 3 to 6 iota square, and we have learned that iota square is equal to -1. So this part will become 6 plus 9 4 13 iota, 6 I square means -6, so just is 30 iota answer. Now see the concept of conjugate of complex number. So in this concept, suppose we have a complex number a plus b iota. So conjugate is a number, just we have to change the sign of imaginary part. Changing sign of imaginary part. Suppose there is a plus bi, we just have to be write same as a real part a, and there is a imaginary part bi. We just have to change the sign of imaginary part. Here the imaginary part is in positive, we just have to like minus. Suppose there is a complex number 3 plus 4 iota, its conjugate is 3 minus 4 iota. Suppose there is a complex number like iota -1, then its complex number is conjugate number is we just have to change the sign of imaginary number, not the real part. Here the imaginary part is positive, we just have to put minus here. This is the conjugate. Let's see another example like 1 minus iota. We just have to change the sign of imaginary part. Conjugate is 1 plus iota. This is the concept. And the another concept that is related to the complex number and its conjugate in multiplication term is that if there is a conjugate number and its multiplication with conjugate number, suppose there is a complex number and its conjugate number, when we multiply this together, suppose this is a plus b iota and another and conjugate is a minus b iota, then its multiplication is just, we can write a square minus bi square whole square, and we know that I square is equal to -1, then it will be a square plus b square. Either it will be the whole square of a plus. So if there is any multiplication related to the conjugate, suppose there is a multiplication of complex number like 2 plus 3 iota, 2 minus 3 iota, so we don't have to multiply like 2 to all, then after 3 I to all. We just have to do like that, multiply a square of 2 plus 3, 4 plus 9. This is the answer. Just have to do, we can do this multiplication in my mind and get the answer in a 1 second. Suppose another conjugate number like 1 minus iota, 1 plus iota. You just have to 1 square plus 1, its real number is 1, so we can just have to put 1 square, that is the 2. Let's see another, like 5 plus 6 iota, 5 minus 6 iota. You can just write 5 square plus 6 square, 25 plus 36, that is 61. So we can see this concept in a short time, so that we can save our time and we don't have to do any mistakes. Because when we learn the conjugate concept, we just have to when we multiply conjugate with complex number or complex number with its conjugate, we just have to get the square of its real part and its sum. Just square the real part and sum together. Now see the last concept related to the division. How can we divide the complex number? Let's understand this concept by an example, that is the 1 plus 2 plus 3i. For this we just have to write 1 2 plus 3i and we have to rationalize this number. There is a 2 plus 3i, we just have to take the conjugate number and multiply up and down. Its conjugate is 2 minus 3i, 2 minus 3i. We just have to put 2 minus 3i up, and I had already told 2 plus 3i, 2 minus 3i. It's a conjugate, it's a complex number, it's conjugate. For this we just can write directly like 2 square plus 3 square, like 2 minus 3i, 2 square 4 plus 9, 2 minus 3i, that is 13, that is the answer is 2 by 13 minus 3 by 13i answer. Let's understand what we do. Suppose this is the number given questions, we just have to rationalize the number. If the complex number is z, then we just have to multiply up and down by its conjugate number. Here is the conjugate number and its complex number, so we can directly write 2 square plus 3 square that we learned previously, that is 9 plus 4 6 13, and we have to separate real part and imaginary part separately. That is our answer. Now do some classwork questions to practice. Suppose the first question is 2 plus 5i minus 4 plus 9. It is a question related to the subtraction of complex number. So I had already told that we just have to subtract a real part from real part, imaginary part from imaginary part. 2 minus 4, it means 6. 5 minus 9i, that is the minus 4i. And the next question is 8 plus 4i, 1 minus I. For this we just have to rationalize from the lower part. We have to take the conjugate of the real part. Its conjugate is 1 plus I, 1 plus I. For upward we just have to multiply, we just have to do multiplication, like 8 1 plus I plus 4i 1 plus I. For the lower I had told that complex number and its conjugate, we just have to take number and its power to sum. So 8 plus 8i plus 4i plus 4i square is a 2. So here is a 4i square. I told I square is equal to minus 1, so it is the minus 4. It is the minus 4. So 8 minus 4, 8 4 12i, divide by 2, so we can write 2 plus 6i. And one thing I want to say, that it is the VVY, it is a very important. We just have to remember that if there is a sum of I square plus IQ I4, if there is a sum up to I4, then its sum is equal to 0. We just have to remember this. And in next video we will do a lot of question practice related to the complex number. We will do around 15 or 20 questions in the next video. So just revise the concept and make your note yourself, so that we can easily revise at the time you want. Because revising again by taking video takes a lot of time, because video we have to see video at once only. From the next time we just have to revise from our note, not from the videos. So have a good day.